and talk about limits. If a sequence has a limit, what that means is there's like a wall it runs into. There's a point beyond which it can't go. I want you to look at the first problem there. If I were to start plotting the points, 1, 4, 9, 16, and so on, if I were to look at those on a number line, here's a number line. If I were to start plotting these points on the number line, would they just keep on going forever and ever and ever? Or is there like at some place out here a wall they won't go past? What's going to happen to these numbers? They're going to keep going, right? So when the question says find the limit, A is actually no limit. There is no limit. They just keep going. And the math word we use for that is divergent. When things diverge, it means they just shoot off into space. And that's what's happening to this sequence. Now, look at the next one, though. What's happening to the next one? Think about these fractions. Okay, so here's 1, here's 0. Here would be 1/3. And wouldn't 1/9 be like here? And wouldn't 1/27 be like here? What's happening to those? They're getting closer to 0. Exactly. Now, for these to go past 0, they would have to become negative. These numbers aren't ever going to be negative. It's going to be 1/81, 1/243. They're just going to keep getting closer and closer and closer. So this one has a limit of 0. You're exactly right. The limit is 0. Now, think about the next one. You don't have to plot them on a number line if you don't want to. Think about it. Oh, did you see what he did? He went like this. Aren't these going back and forth, positive, negative? And, okay, I'm 0, all right? So the first one is -2. And then the next one is 4. And the next one's -8. They're flipping back and forth, but every time they flip, what do? Move farther apart. No limit. No limit. That's divergent. So C is another. You can write no limit or you can write divergent. Either one. But there isn't a limit. Now, the next D through H we have done before. When you did horizontal asymptotes, do you remember I boxed in the top and the bottom when we did horizontal asymptotes? You know what I'm talking about? We had, like for letter D, our equation looked like this. They weren't N's, they were X's, but they looked like that. And I said, do this. That was finding the limit. So the limit for letter D is 1, because N over N. It's the same thing we did before. The horizontal asymptote, we box in the biggest power, so we have 1n over 1n, so that's 1. How about E? What's E going to be? 2/3. Why is it 2/3? Because it's 2n over 3n, right? What about F? 4/5. Remember, you look at the highest power. And in letter F, isn't your highest power n squared? So I box those in, and I have 4/5. No, the next one you got to be careful. When the big power is on the bottom, it's 0. So the limit is 0. And that's because, kids, if I rewrote it, if I rewrote the problem, I have 0n squared over 5n squared, right? There's no n squareds on the top. And what's 0 over 5? That's 0. When is it no solution? When the zero's on the bottom, which is what happens in the next problem. Because in the next problem, we have no n squareds on the bottom. So when we box them in, we get 8 over 0, which is no limit. So before you said no solution or no asymptote, now you're going to say no limit or divergent. The word for no limit is divergent. So you can either say no limit or use the math word, divergent.
So zero's on top, it's 0.
Yep.
So zero's on the bottom.
Yep. Now, so would everybody agree that D through H are kind of the same kind of problem? So when they look like that, we're going to box in our powers and do the horizontal asymptote thing. Now, I through L are a different kind of problem, right? When you look at them? Okay, so here's what I want you to do real quick. I want you to take your calculator out. I'm going to have you do two things. I want you to do 2 times 2 times 2 times 2 times 2. Just keep multiplying by 2 and watch what the answer does. Are your numbers getting bigger or smaller?
2 times 2 times 2.
Yeah, just do 2 times 2, get an answer, then multiply by 2 again, get an answer. You don't even need a calculator to do this. You can probably do it in your head. What's happening to those answers? They're getting bigger, right? Now, take 0.5 times 0.5, get an answer, and then do times 0.5 again, get an answer. What's happening to those?
Smaller.
They're getting smaller. When you raise 2 to a power, it gets bigger. But when you raise 1/2 to a power, it gets smaller, right? That happens with every single number, not just 2 and 1/2. If the number is bigger than 1, you're not going to have a limit. If the number is less than 1, like 1/2, 1/3, 2/3, 3/5, if it's less than 1, your limit is going to be 0. The terms are just going to keep getting smaller and smaller, and your limit's going to be 0. So when you have these things raised to powers, the answer will always be either no limit or 0. And it depends on one thing, the size of the number in the parentheses. So for letter I, it will be 0, because 2/3 is less than 1. For J, it will be no limit, because 5/4 is more than 1. K will be no limit, because 1.5 is bigger than 1. And L will be 0, because 0.8 is less than 1. The exponent does not matter. The exponent does not matter. Now, let me rephrase that. If I threw in negative exponents, it would matter, but I'm not going to do that to you. So for you,
You'd have to flip it,
the
right?
exponent,
If it was negative.
yes, and so then the rules would be reversed.
Right.
Yeah, but I'm not going to do that to you, okay?
What's the limit mean?
That means the limit, find the limit.
Oh.
You're finding limits, except instead of writing out the word, I use the actual math definition, or the notation, I mean, okay?
When I thought when the infinity's there, I thought it would just be no limit for all of them for a second.
No, what that means is, you're letting your exponent get bigger, well, on these exponent problems, you're letting your exponent get bigger and bigger and bigger, which just means you're multiplying
Going
more and
to-
more times, yeah.
Figuring out if it can be
Right.
infinity or not.
Exactly. Okay, so just to make sure that we are all on track with that, I'm gonna write a couple of problems up here And I want you to figure out the answer, but don't say it out loud. Just hang on to it for a minute, and let's see if you can do it. So we're going to find the limit of this, and we're going to find the limit of this.
Limit of 0.
All right, so just take a minute and see if you can answer this. Both of them are easy. Shouldn't take you a ton of time, and there really isn't any work to do. We're just making sure you know the rules. All right, what'd you get for the first one? Yes, because what's the rule? This has to be less than, well, if it's less than 1, the limit is 0. If it's more than 1, there is no limit. Okay, good. What about this one?
No limit.
It's actually 3/5 Trey, because we have n cubed over n cubed. So that's what we box in. So the limit would be 3/5. None of this matters, so do not get caught up in all that. None of it matters. It's only the highest power that you look at. Okay? Everybody got that all right? Okay, so that homework you should be able to complete. All right, now, let's look at the next set of problems here. And I want you to think about this problem. I'm going to write this down. I want you to think about it. Let's suppose that the I don't even know how rugby points work, so I'm making this up. But let's suppose the rugby team scores 5 points in the first game, and 11 points in the second game, and 17 points in the next game, and so on. Here are 2 questions. How many points, this is not in your notes, I'm doing this extra. How many points will they score in the 10th game? How many points will they have scored in 10 games? Now, do you see the difference between those 2 questions? Exactly. The first one, if this is how many they scored in game 1, and this is game 2, and this is game 3, aren't we just looking for the 10th number out here in this list? Isn't that what we're looking for with that one?
Yeah.
Okay, we know how to find that, so we're going to find that in a minute. Because what kind of sequence is that? Arithmetic. And we have a formula. We can find the 10th term. We'll do that in a second. This one, though, is asking me to do what? The total of all of them. So this one wants me to actually add all these up all the way out to the 10th one. Right?
Yeah.
Okay, so that's new. That's brand new. Let's pause on that for a moment. Let's do this one. We know how to do this problem already. This is arithmetic. So here's my formula. Right? And I want the 10th term. The 10th term will be the first term plus the difference. What's the difference here? 6 times 9. So they're going to score 50, is that 59? They're going to score 59 points in the 10th game. Now, we have a choice. To find the sum, we can take out our calculator and just start adding them all up, right, till we get to 10 of them. which isn't that bad, but it would be terrible if we had 100 games. That would take forever. So luckily we have another formula for this. Okay? Here is the formula. Oh shoot. Well, you remember what it is, right? I got it written down here. Here's the formula to find an arithmetic sum. So if you have an arithmetic sequence and you need to sum it, add them up. Here's the formula. Jameson? Okay, now, N stands for the same thing it stood for before. So if I am summing up 10 scores, then N is 10. So I would have S sub 10. So if N is 10, then my formula says 10 over 2, A sub 1 is the first term, which is 5, plus, what's this?
10.
A sub 10, and didn't I just figure that out? A sub 10 is 59. So basically, I'm going to take 5 times 64. What is that, 320? So they would score 320 points in their first 10 games. And we're going to spend a lot of time. That wasn't even in your notes. That was just extra stuff. I got one more thing to show you. Where did that formula come from? You're not going to believe it. It was developed by a little kid. I'm dead serious. Carl Friedrich Gauss, back in many, hundreds of years ago. When the little boys went to school, the teacher said, it was like a Friday after, true story, look in the encyclopedia. The teacher was getting frustrated. I mean, they're like third grade kids or something. He's getting frustrated. It's the end of the day. They're all going wild. And he says, okay, boys, here's what I want you to do. I want you to add up all the numbers from 1 to 100. Now, that's a tedious task, but it's something that third or fourth graders can do. You know, 1 plus 2 is 3, 3 plus 3 is 6, and so on. You know, add, okay. So the teacher says, okay, guys, this is what I want you to do. He sits down at his desk thinking, okay, they're going to be quiet and calm for at least, 15 or 20 minutes. Oh, no. Immediately, up comes little Carl Friedrich with the answer. And the teacher's like, where did you get that answer? And he said, it's easy, teacher. You asked me to do this, but I know that addition is commutative, so it would be the same thing if I did it in the other order. Right? That's true. If I add these two together, 2s, look at all these, that would be 101. What's this going to be? 101. All the way down the line is going to be 101s. So 2 sums is 100 101s, because there's 100 of those numbers written across there. So 1 sum would be 50 101s. And that's the answer to the question. Now, what does that have to do with what you just did? Well, where did this 50 come from? Half of 100? So n over 2? Where did the 101 come from? First term plus last term? Indeed. Indeed. Okay, let's clean off the desk. Your your 9.4 homework will be due on Monday.